this is question 1 from the Acids and Bases worksheet, and it's taken from the Eastern Cape paper, paper 2, higher grade, November 2000. So yes, it's a while ago, but the content is still the same for acids and bases. It hasn't really changed. So they tell us in an acid-base reaction, 400 centimeters cubed, and that's not going to help if you can't see it. So 500 centimeters cubed of a sodium hydroxide solution is completely neutralized by 680 centimeters cubed of a sulfuric acid solution. The equation for this reaction is H2SO4 plus 2 NaOH. So they've given us the balanced equation, makes life a lot easier for us. And they tell us that the Na, and it gives you sodium sulfate and water, right? Then they tell you the pH of the base solution before any acid is added is 13,8 to 25 degrees. Now, the only reason why we're giving you a temperature is because the ionization for constant for water is temperature dependent, because it's an equilibrium constant, and we know equilibrium constants are temperature dependent. Now they say to you, show my calculation that the concentration of the NaOH is 0.631 moles per decimeter cubed. Usually at this juncture, if we want concentration, we would need mass, we would need the mass, okay, which we don't have. We are asked to prove that this is the concentration. Now what they have given us is the pH, and they told us it's 13,80. If we remember, pH is the negative log of the H3O plus concentration. So essentially, by giving us the pH value, we can work out the pH. Okay, so this is 13,80 negative log H3O plus concentration. Now this is a little bit of a maths trick, okay? And if at this point you don't know how I get there, please don't worry about it. You're never going to have to prove it. But we use logs that are base 10. So it means that the H3O concentration is equal to 10 to the power of 13,80. Negative 13,80. Alright, so this is what I'm telling you, is if pH is the negative log of the H3O plus concentration, then to get the H3O plus concentration, it's 10 to the negative of whatever the pH is. That's a very important thing to take note of. Okay, it's finding the inverse of the log. They're not going to give you the second part of that equation, so you do need to know that, alright? So now, if I put 10 to the minus 13,8 into my calculator, I'm going to get that this concentration, I'm going to keep 3 decimal places, is 1,585 times 10 to the minus 14. Why have I done that? Because I know that the H3O plus concentration times my OH minus concentration must be equal to 1 times 10, oopsie, I'll put times twice, shall I? 1 times 10 to the minus 14. So that means this is 1,585 times 10 to the minus 14. I didn't really space this out well. OH minus, and that's equal to 1 times 10 to the minus 14. We're going to divide both sides by 1,585 times 10 to the minus 14. So that means that my OH minus concentration is 0.631. Now, of course, at this point, you're going, but we still don't have the NaOH concentration. Actually, we do. NaOH will dissociate into Na plus and OH minus ions, okay? And they are, so sodium hydroxide is a 1-to-1 relationship with the OH minus. So whatever the OH minus concentration is, that's the sodium hydroxide concentration. So in other words, the NaOH concentration is equal to the OH minus concentration, 0.631 moles per decimeter cubed. Alright? Now, if we need this value later on, and say perchance you didn't get this value, don't worry about it, because you can assume it's correct. If they tell you to prove a value, you must get to that value. Not maybe, not almost, you must get to that value. They're not going to tell you to prove a value that is incorrect. Okay? If you don't get to this value, assume it's correct and use it in any calculations you need to later on. Alright. So, next one, difference between a strong base and a concentrated base. Now, I'm not going to write this all out. You guys can manage that. A strong base ionizes completely, okay? So we have a high percentage ionization, lots of ions in the solution, okay? Concentrated, there's a large number of moles of base per unit volume. Okay, I'm looking for the fact that for a strong acid or base, alright, I'm looking for the ionization, the amount of ionization. When it comes to concentration, I'm looking essentially for the definition of concentration. Okay? So, 1.3 now wants the mass of the salt used to prepare the solution. I know the concentration. We've just worked that out. They also said to us that we made 500 centimeters cubed, so I know the volume. But of course we're working with concentration, so it needs to be in decimeters cubed. We divide by 1,000. I want to know what the mass is, so I'm going to need the molar mass. You are welcome to work out the molar mass separately, or you can do it as part of the equation. I sometimes like to do it separately just because when they're fairly complicated molecules, sodium hydroxide isn't one of those. It's easy to get a bit flustered when you put it all into your calculator. Okay? We know concentration is mass, molar mass over volume. We know that that's 0.631. Mass is what I'm looking for. My molar mass is 40. My volume is 0.5. So I'm going to end up going 0.631 times by 40 times by a half, and we get 12.62 grams. Okay? Quite nice. With these questions, it's about taking this one step at a time. And essentially, in this question, 1.1 and 1.2 were the acid-base questions. 1.3 and 1.4 are actually stoichiometric calculations. That's what it is. Okay. Now they say, calculate the number of moles of H3O plus, okay, this is acid-base, effectively used in the neutralization process. What we need to remember in the neutralization process is when we neutralize this, okay, the number of moles of H2O, of OH minus, must be equal to the number of moles of H3O plus. Okay? Those two must be equal to each other so that they can cancel each other out. I know that if we have different acids and base strengths, we can end up with a salt that is either acidic or basic, but that's not what they're asking. They're saying when we neutralize them, those two values must be equal. In other words, what is the number of moles of OH minus? That's what they're asking. And remember, from the NaOH, we know that this becomes Na plus and OH minus. So the number of moles of NaOH will be equal to the number of moles of OH minus. We can work out the number of moles of NaOH. Number of moles over volume. We know the concentration is 0.631. We want N. That's 0.5. N is now 0.316. I've rounded it off to 3 because I used 3 earlier on. Therefore, okay, the number of moles of H3O plus will also be 0.6 moles. Done. Really not as bad. You've just got to think through it. It's applying what you know, one step at a time.